We are now on part 2 of chapter 12, and in this section we are going to talk about forwarding, which is also called resolving internet names, and forwarding is also known as pushing the query upstairs. But let's first review the purpose of DNS. The purpose of DNS is to perform host name resolution, meaning the client asks the DNS server the IP address of the web server. The client sends a query to the DNS server to find out the IP address of the web server. With forwarding, also known as resolving internet names, also known as pushing the query upstairs, with forwarding, it's when the client is requesting access to a website from another domain, such as Microsoft.com. Now, in all of our previous examples, the client is in CCBC, the web server he's trying to access is in CCBC, and the DNS server is CCBC's DNS server. So this is all occurring within the same domain. The user wants to access a web server which is in the same domain. But now with forwarding, we're addressing the issue is where the client is trying to access a website from another domain. For example, Microsoft.com. So here's how forwarding works. The user types www.microsoft.com, presses the enter key, and the query goes to the CCBC DNS server. The CCBC DNS server only has the IP addresses of web servers within CCBC. The CCBC DNS server does not have the IP address of Microsoft.com. So what the CCBC web server does is it pushes the query upstairs to the root server. The CCBC DNS server sends a query to the root DNS server, and the root DNS server tells the CCBC server the IP address of the .com server. Step number 4. So then the CCBC DNS server sends a query to the .com server. The .com server tells the CCBC server the IP address of Microsoft's DNS server. So then our DNS server queries Microsoft's DNS server, finds out the IP address of Microsoft's website, sends the IP address back to our DNS server, which sends the IP address of Microsoft.com's web server back to the user's workstation. A lot of steps there, huh? Let's do it again. The user wants to access Microsoft.com. So the user types Microsoft.com, sends a query to our DNS server at CCBC. Our DNS server pushes a query up to the root server. The root server tells our DNS server to contact the .com server. Our DNS server contacts the .com server. The .com server tells our DNS server the IP address of Microsoft's DNS server. Our DNS server asks Microsoft's DNS server for the IP address of Microsoft's web server. Microsoft's DNS server tells our DNS server the IP address of Microsoft's web server, and our DNS server sends the IP address of Microsoft's web server back to the client. This is DNS forwarding. Let's look at configuring DNS forwarding. Let's look at configuring DNS forwarding. Initially, you don't have to configure DNS forwarding. By default, queries will be forwarded to root servers, so you don't need to configure that. To get a list of the root servers, you look at a tab called Root Hints. Root Hints contains the list of the IP addresses of the root servers. So if we go to our DNS server and we right-click, we select Properties, and then we select the tab that says Root Hints. This has a list of all the IP addresses of all the root servers. So initially, you don't need to configure root hints. It's all, by default, queries will be pushed to the root servers. So now let's look at configuring DNS forwarding. If you are in a subdomain such as essex.ccbcmd.edu, you might want to configure your DNS server not to push the queries directly to the root server, but to push the queries to the next higher level DNS server, meaning ccbcmd.edu. So to configure DNS forwarding, we are configuring a DNS server at Essex to push the queries to the DNS server at CCBC. So to do that, we select our DNS server, right-click, and select Properties. There's root hints. But if we click on Forwarders, this is where we type in the IP address of the CCBC web server. So we click on Edit, and we type in the IP address of the web server where we want the queries to be pushed to, and we click on OK, and we can see that instead of queries being forwarded to the root server, queries will be forwarded to the CCBC server. And if the CCBC server can't satisfy the queries, then it will push the queries up to the root server. Understanding DNS referrals and queries. A DNS client request is a query that is asking the DNS server for the IP address of a web server. And those requests fall in two general categories. An iterative DHCP query is where the client request is satisfied by the local DNS server. And we already did that one, where all of our activity was within the CCBC domain. A recursive DHCP query is a query which is forwarded upstairs to another DNS server. Iterative and recursive. Recursive query is a query which is forwarded to another DNS server. So now let's look at DNS caching. So you know what forwarding is. Now we're going to look at DNS caching of forwarded queries. Caching means to hold on to something for a while. To cache means to hold on something for a while. So we're going to configure the DNS caching of forwarded queries. The reason we do that is for a faster response time for subsequent DNS client queries. So let's look at DNS caching. So first let's look at not DNS caching. User sends a query to the DNS server. DNS server sends the query to the root server. Root server sends the query to the .com server. .com server sends the query to Microsoft server. Microsoft server sends the IP address of its web server to our DNS server, and our DNS server pushes the query down to the workstation. Now with DNS caching, the IP address of Microsoft's web server is held in the IP address of our DNS server. Sorry, it's held in the RAM of our DNS server. That's called DNS caching. So 5 minutes later, when another user tries to access Microsoft.com, the query does not have to be forwarded up to the root server because that query was just resolved a few minutes ago. And that the results of the resolution of that query are stored in the RAM of the DHCP server, and thus this client gets the response immediately. It doesn't have to wait for the query to be pushed up to the root server. DNS caching is where a previously resolved host name is stored in the RAM, in the cache of the DNS server. And that makes it faster for subsequent users who make similar DNS queries because the queries don't need to be forwarded to the root servers. And this also reduces the load on the wide area network link. So how long is a record held in the DNS cache? To find that out, you look at the SOA, the start of authority record, to determine how long a DNS record will be held in the cache. If we go to our DNS zone, we see there's a record that's called the SOA, the start of authority record. If I right-click on that record and select properties, the start of authority record shows the TTL, the time to live, and that indicates that that DNS query, the IP address of Microsoft's web server, will be held in the RAM, will be held in the cache of the DNS server for 1 hour. Start of authority record determines how long a learned DNS record will be held in the cache. Now let's look at configuring a caching-only server. You already know what DNS caching is. Let's look at a caching-only server. The purpose of a caching-only server is to reduce DNS wide area network traffic, and it is typically used in a SOHO, a small office, home office. Typically used in a small office environment. So let's start out with a statement of the problem. Why is there a need for a caching-only server? What we have here is a small network, and this network has no DNS server. This network uses the DNS server of our internet service provider. So the first user, the problem is this makes for heavy DNS query traffic on the wide area network link. So here's the example. A user wants to access some website, such as CCBC. And this is not CCBC right here. This is just some small office. So the query goes to the DNS server. The query goes to the wide area network link to the ISP's DNS server, and the ISP's DNS server sends the IP address back. Second user wants to access the same website. Query goes to the ISP's DNS server over the wide area network link, and the DNS server responds. A third user at the same site wants to go to the same website, but his query goes over the wide area network link to the DNS server, and the statement of the problem here is this causes heavy DNS query traffic on the wide area network link. So the solution is to get a DNS caching-only server. The purpose of a DNS caching-only server is to really just forward and to cache, to hold DNS queries. So the first user tries to access a website, and the query goes to the caching-only DNS server. The caching-only DNS server pushes the query up to the ISP's DNS server, and then it learns the IP address of the website the user wants to go to and sends the IP address back to the user. No big difference there. Here's the big difference. The next employee wants to access the same website as the previous employee. That website goes to the caching-only DNS server. Since the caching-only DNS server just learned that IP address a minute ago, that IP address is in its cache, is in its RAM, and therefore it can immediately respond to the user's query. This assumes that this user wants to access the same website that his coworker just accessed a minute ago. So with a caching-only DNS server, it provides faster response time for subsequent users who are making DNS query, and it reduces the load on the wide area network link. And most of us in our homes, our wireless routers are already caching-only DNS servers. Now let's discuss hosting internet domains. The question is, do you want to host your own DNS server, or do you want to use your your internet service provider's DNS server. It's really based upon how big you are. If you're a large organization like the Community College of Baltimore County, we've got our own mail server on site, and we have our own web server on site, and we have enough personnel on staff that we can maintain our own DNS server. But if you have a small office or a home office, then you're not going to set up your own DNS server. You would typically use your internet service provider's DNS server. That's what we all do in our home wireless networks, and that's what most small companies do. SOHO, small office, home office. Now let's discuss integrating DHCP and DNS. In Chapter 11, the previous chapter, we saw that we could configure the DHCP option for DNS. Now, we previously saw that you could manually configure TCP, IP, and DNS. In other words, when you're configuring TCP, IP for DNS, you are telling the client where to send DNS queries to. And if you recall, under TCP, IP properties, the fourth variable to type in is the IP address of the DNS server. So we go to every single DHCP client, we go to every single client, and we type in the IP address of the DNS server. Well, as you know, it's awfully labor-intensive and time-consuming to walk around to each computer and to type in the IP address, subnet mask, default gateway, and DNS server. Instead of manually configuring TCP, IP, and DNS, which can be time-consuming and labor-intensive, what we do is we use the Dynamic Host Configuration Protocol to configure the client with the IP address of the DNS server. We use the DHCP server and the DHCP option to tell the client the IP address of the DNS server. We did it in a previous chapter, but let me just review it. So we go to the DHCP Management Console, and under Scope Options, if we right-click and we select Configure Options under the checkbox that says DNS Server, this is where we type in the IP address of the DNS server. And that way you don't have to walk up to every single computer to type in the IP address of the DNS server. Configuring the DNS client can be done two ways. You can walk up to every single workstation and type in the IP address of the DNS server, but a much more efficient way to go is to use DHCP, using the to push the IP address of the DNS server down to the DNS client. Now let's discuss creating host names, and what that means is assigning host names to computers. As you recall, when we first did the server install, it was assigned a randomly generated name. So the first thing we did is we went in and we selected change, and we cleared out the randomly generated name, and we typed in some sort of a host name. A computer name is a host name. In this example, I just called the server Server 1. So when we create host names, the question is, what should you name a computer? And the answer is we should keep it simple and descriptive. For example, we might want to call our file server Server 1. The host name for the database server might be called Database Server. The host name for the mail server might simply be called Mail. The host name for the registration server might be called Registration. And typically, the host name for a web server is usually called www. Avoid certain host names, particularly host names that are long and difficult to spell. A name like Albuquerque server or Schenectady server, very difficult for users to type in. Keep it short and descriptive. Resource records. There are multiple types of resource records on a DNS server: host, CNAME, NS, start of authority, and PTR. And we've already looked at the host record. The most common resource record is a host record. And a host record is just a computer name and an IP address. When you think of DNS, you think of host records. If we look at our DNS server, the DNS client asks the DNS server the IP address of the web server. The DNS server has host records on it, and a host record is the name of a computer and an IP address. Here's an example of a host record here. Server 1, this shows server 1 and its corresponding IP address. This shows the web server and its corresponding IP address. These are called host records. Sometimes they call them A records for address. This is the most common type of DNS record, but there are other types of resource records as well. For example, the name server record. NSA stands for name server, and a name server record simply has the name of the DNS server. So you can see here that the NS record, the name server record, is server1.ccbcmd.edu. NS record is the name of the DNS server. And then another type of record is called the C name or canonical name, and a C name is an alias. So here's the situation of when you would use an alias. The name of the server is called student-registration-server-Catonsville H-Tech Building-208. Now you might say that's a pretty good name for a server. It's descriptive. It tells us it's a student registration server. It's on the Catonsville campus. It's in the H-Tech building, and it's in room 208. But that's an awfully long name. We just want the students to be able to type reg.ccbcmd.edu and have that take them to the registration server. And to do that, we create an alias. When we create an alias, the user types reg.ccbcmd.edu, but the student is directed to the registration server, which has this long name. So the purpose of the alias is just to make it easier for the user. So let's create an alias. Here is the student registration server with a long IP address. So I'm going to right-click and I will select New Alias, what they call C name record. And under alias or C name, I type in the name that I want the users to use. For example, simply reg. When the user types reg.ccbcmd.edu, I want them taken to this fully qualified domain name. I want them taken to student-registration server-HTech208. And I click on OK. So now when the user types reg, they'll actually be redirected to the student registration server, and that's the IP address of the student registration server. Now let's discuss what's meant by an SOA, or Start of Authority record. But before we discuss Start of Authority, let's discuss what's meant by replication. For purposes of fault tolerance, we typically have a primary and a secondary DNS server. And the primary server replicates to the secondary DNS server. So if the primary server crashes, that's okay. We've got the secondary DNS server. Replication means the copying of the contents from the primary DNS server to the secondary DNS server. So the purpose of the Start of Authority record is to show the frequency of replication. So if I go to the SOA, Start of Authority record, and I right-click on that guy, and I select Properties, we can see the Start of Authority record shows that replication will occur every 15 minutes between the two DNS servers. Start of Authority record shows DNS server configuration parameters, particularly frequency of replication. And the last type of record we're going to look at is what they call a PTR record. And you may recall that when we made earlier host records, there was an option here, a checkbox that says create associated pointer record. So to understand what a pointer record is, we have to step back and discuss what's meant by reverse name resolution. Now, you may have noticed we have forward lookup zones, and that's what really we've been working with in this class so far, but they have these reverse lookup zones that are used for reverse name resolution. Now, you already know what normal name resolution is. They call that forward lookup. That's given a host name, the DNS server provides the IP address. You type CCBC, the DNS server tells you the IP address. That's forward lookup. But in a reverse name resolution, that works the other way. Given the IP address, the DNS server returns the host name and domain name. And usually it doesn't work that way. Usually the client, given the host name, the client wants to know the IP address. But in this situation, the client has the IP address, and now it's asking the DNS server, what is the host name that corresponds to this IP address? And the reason or a circumstance under which you would care about reverse name resolution is if you're trying to block incoming traffic based upon domain name. For example, if we configure our website for security, we can select IP address and domain name restrictions, and we can grant or deny access based upon domain names. So if I want to block everyone, from HCC, Howard Community College, I would select address restrictions, deny access to hcc.edu. Block all traffic from hcc.edu. So when a packet comes into this web server, if it's from Howard Community College, it's going to be blocked. But a packet has the destination IP address in the header. It doesn't have the host name in the header. A packet has the destination IP address in the header. So to determine if this packet is in fact from hcc.edu, then our DNS server performs reverse name resolution. So given the IP address of this packet, which is coming to our web server, do we block it or not block it? So our DNS server does a reverse lookup and returns the host name and the domain name. So if it's HCC, we do block it. If it's not HCC, we don't block it. The typical example of reverse name resolution is when we're blocking traffic based upon domain name. A PTR, a pointer record, is used to perform reverse name resolution. So a DNS zone contains resource records, and the most common type of a resource record is called a host record, but there are other records as well. CNAME is an alias, NS is a name server record, SOA is start of authority, and PTR is a pointer record. Now let's discuss integrating DNS and Active Directory. If we go to create a new DNS zone, we previously created a primary zone, but we would also have the option to store the zone in Active Directory. So why would we want to store the zone in Active Directory? One of the big reasons is because Active Directory supports multiple master replication. Now, if you're using DNS, one DNS server replicates to another DNS server in case the first DNS server crashes. And single master replication is where it's one-way replication. The primary DNS server replicates to the secondary DNS server. So you can only add records. You can only add records to the primary DNS server, and then it replicates to the secondary DNS server. If the primary DNS server crashes, the secondary DNS server will still perform hostname resolution, but you won't be able to add any new host records until you get the primary DNS server up and running. That's with DNS. But if you use Active Directory, Active Directory uses multiple master replication. With Active Directory, multiple master replication means you can add a record to any one server and it will replicate to the other server. Active Directory uses multiple master replication. So if we want DNS to use multiple master replication, then we integrate DNS and Active Directory. An Active Directory integrated DNS zone is where the DNS database is stored in Active Directory, and therefore it takes advantage of multi-master replication, which is a function of Active Directory. And we will go more deeply into Active Directory in Chapter 13. Chapter 12, Summary. In this chapter, we discussed the DNS hierarchical architecture. We looked at hostname resolution, which is the most important thing to understand about DNS. We looked at a DNS server, which contains host records, and a DNS client, which is also called a resolver. We looked at creating zones, which are used to hold host records, and then we looked at adding host records, and we saw that there are three methods of adding host records. We looked at configuring forwarding, and we looked at DNS caching of forwarded DNS requests. We looked at integrating DNS and DHCP. We looked at the different types of resource records and at DNS fault tolerance. We looked at reverse name resolution and at integrating DNS and Active Directory. And this concludes Chapter 12. Thank you very much, and have a nice day.